Hello everyone. We'll wait till 6:15 and then we'll start the session. I've allowed your microphones, so can you just confirm if my screen is visible to you and the slides are changing as well? Yes, is my screen visible to you guys? Can someone just answer this or respond it in the chat section if you're comfortable? All right, let's start the session. Hello everyone. Welcome to the 8th weekly discussion and doubt clearing session of the NPTEL course on concrete technology, NOC24-CE46. which is taken by Professor B. Bhattacharya of IIT Delhi. I am Ashirvad Satpathy. I'm a PMR research scholar at IIT Delhi. And what I do is I take these weekly sessions of 2 hours where we discuss the assignment problems that have been given to you in the previous week's NPTEL lectures. And we also take up any doubts that you might be having regarding the previous week's lectures. There is another officially assigned teaching assistant to this course. His name is Debojyoti. He usually takes his weekly sessions on Saturdays from 6 to 8 p.m. And I take my weekly sessions on Mondays from 6 to 8 p.m. I would also like to mention that the previous week's uh, session videos have been uploaded on YouTube and the links have been shared with you in the chat section of this meeting. And the lecture slides that we use during these sessions, I have also uploaded those to the OneDrive folder that we have been using throughout this course, and you can check that out if you want. All right. In today's session, we'll be discussing the week 7 assignment 7 problems. There are around 7 problems, and this week's lectures were more or less regarding the workability and then pumping and different methods, empirical methods of measurements of flowability of concrete, how to pump the concrete, what are the different types of pumping heads available, and it was also discussed about the ready-mix concrete and the batching plants that are used, that are set up in very large projects, and about vibration, compaction, and all those aspects of fresh concrete. So all these assignment questions are more or less related to those aspects of fresh concrete. And at the end of the session, we'll be taking any doubts of the week 7 lectures that you might be having. All right. To start with, the first question was, what is the maximum height of free fall for fresh concrete allowed? And the options were given 1.5 meter, 2 meters, 2.2 meters, 1.7 meters. Can somebody answer to this question? And I mean, why does the height of free fall matter to us anyway? I mean, why is it important for us to restrict the height of free fall of fresh concrete? Can somebody answer? Yes. Suvita, Vidya, Urvashi, Pavitra. Anyone? What is the maximum height of free fall for fresh concrete allowed? It was also discussed in the lecture as well. All right. So the correct answer to this question was given in the assignments as 2 meters. So it was mentioned as 2 meters, but the IS 4 Indian standard size 456 2000. I guess this parameter, this stipulation was as per the previous versions of the IS 456 code, but the Indian standards 456 2000 mentioned that as a general guidance, the maximum permissible free fall of concrete may be taken as 1.5 meter. So yeah. So this has been taken from the Indian Standards for IS 456 2000. And I was talking about why is the maximum height of free fall of fresh concrete important to us. And it is when the concrete is in fresh state, it's in a plastic state, it is basically aggregates suspended in a medium of cement paste, right? Cement paste. So aggregates meaning fine aggregates, that is sand and coarse aggregates, suspended in a medium of cement and water, cement paste basically. And cement paste is the one that is driving the whole of the block of the concrete as a single homogeneous material. So it is the one, it is the part that is responsible for flowing, making the concrete flow. Now when you place the concrete from a height, what happens is the cement watery paste will lie around at the same location when you place it. I mean, the location at which you're pouring the concrete at, and the aggregates, due to their size and due to their, I mean, their larger size and their heavier nature, they'll bounce off on the ground and they'll settle down at a greater distance from the pouring site itself. So that will result in an inhomogeneous mixture of the concrete, and that will result in honeycombing and several other effects of like inhomogeneities will arise within the concrete, and therefore that will have different other effects on durability as well as the structural performance of the concrete at a later stage. So we do not want that. Therefore, it is mandatory to restrict the maximum height of free fall of a fresh concrete, right? So this is the correct answer to this question. Moving on to the second question. For the discharging of concrete from the bucket, what is desirable? Rolling over and dropping from top, have narrow and inclined opening at bottom, bottom wide opening, or none of the above? Which of these methods is desirable for discharging of concrete? Discharging meaning, I mean, you have to pour the concrete. So while pouring the concrete from out of the hopper or the storage truck, so what kind of outlet shape and um outlet, property should is desirable in order to um, place the concrete without any effects of segregation or yeah, without making any inhomogeneity arising within the concrete itself. So is rolling over and dropping from top, meaning that you have essentially the tilting drum kind of a setup wherein you uh, I mean you tilt the drum containing the fresh concrete from the hopper truck, and then you roll it over and drop the concrete from the top. So the concrete from the top hits the ground first, while the concrete from the bottom hits the ground at a later stage. Then there is have narrow and inclined opening at bottom. Inclined, you essentially let the concrete flow out from the bottom through an inclined pathway, right? And then there is a bottom wide opening. So in the second one, it was a narrow opening. In the third one, it is a bottom wide opening. But again, you're pouring the concrete from the bottom, meaning that the concrete at the bottom part of the storage truck itself will be hitting the ground first, and the top part will be hitting the ground later on, or none of the above, which is desirable for discharging the concrete. Yes, anyone? Would you answer to this question? So I'll just roughly give an idea like this. Just rolling over and dropping from the top. Think of it as what are the problems associated with all of these methods of discharging the concrete? What kind of problem might be faced during this kind of situation? So this is basically this is the hopper, and it has a very narrow opening, and then there is an inclined pathway, pour the concrete. Narrow opening and inclined then there is a bottom wide opening. So it is normally a bottom wide opening. So essentially you have some kind of a door over here and you let the door open, so for it to flip directly. So okay, try to answer this question. Whenever you're discharging the concrete, you would want the bottom part of the concrete to be opened so that the concrete flows out by the of its gravity, effect of gravity, and not by rolling over and dropping it from the top. Because as we have discussed in the first question itself, when you drop it from a height, essentially when you're rolling over the storage drum of the truck, you are dropping the concrete from a height. And when you're dropping the concrete from a height, these larger aggregate particles, due to the impact on the ground, they will be bouncing off the ground and will be accumulating at a larger diameter from the pouring site, while the paste or the grout, the cement paste itself, will be accumulating at the pouring site itself. So that will cause an inhomogeneity in the concrete. So it will make the concrete inhomogeneous in nature. We don't want that in concrete. Therefore, we want to place the concrete from the bottom. We want to open the bottom part of the storage drum so that the concrete will flow out by the effect of gravity. So that is for sure. We're not dropping it from top. So this is not the correct answer, right? Then having a narrow opening at the bottom is not desirable, because when you have a narrow opening and an inclined pathway, it is possible that the cement paste, which essentially forms a lubricating layer while pumping the concrete, this cement paste will get stuck on the inclined surface, and when you pour the concrete out, so the the larger the number of surfaces the concrete goes through, the paste will stick on those surfaces. Even though we want the surfaces to be non-absorbing, but even then, some of the paste gets stuck on these surfaces. And therefore, when we pour the concrete will have less paste in it, and paste, as we know, is the reacting part. The cement paste is the reacting part in concrete. Therefore, lesser the paste, there will be the concrete will be more stony in nature. It will have a lot of large aggregates in the concrete, and that will result in improper compaction and loss of strength, and it will also affect the durability as well. So because of high amount of air points. So we do not want an inclined opening at the bottom. So the correct answer to this question is bottom wide opening. We want to place the concrete from the bottom of the hopper truck, and the opening should be wide enough so that the concrete, all of it, directly gets poured at the pouring site itself, and due to its own angle of repose and due to its own slumping action of the concrete, it will settle down. If it is a self-compacting kind of concrete, it will it doesn't need any kind of an external vibration. But if it's not a self-compacting concrete, it's a pumpable or even a stiffer concrete, then you'll have to provide an additional vibration, additional compacting effort after the concrete has been poured on the formwork, right? But the pouring, while pouring, the hopper or the storage truck should have a wide bottom opening. So that is the correct answer to this question. Moving on to the third question: to overcome the compaction issues during underwater concreting, which of the following is a preferred property? And they have listed three properties: self-compacting, anti-washout admixture, pre-packed grouts. So, which of these properties, or a combination of these properties, are desirable to overcome the compaction issues during underwater concreting? Yes, anyone would like to answer to this question? Why do we have compaction issues in underwater concreting? And one of the properties is very clear from here. When you face a compaction issues, straight away you can go for self-compacting concrete. So yeah, that is for sure, because you self-compacting concrete doesn't need any external effort, compaction effort. So that is understandable. What is an anti-washout admixture? What are pre-packed grouts? Yes, anyone? Why do we face issues of compaction during what underwater concreting? Or can we go for a direct vibration-based compaction method for underwater concreting? If not, what is the issue? Why can't we go for a direct vibration-based compaction underwater concreting? Is anyone? Would you like to try? I've already helped you one third way there. So, Srinivasan, Vidya, Urvashi, Pavitra, Suvita, APC. The question is, to overcome the compaction issues during underwater concreting, which of the following is a preferred property in your concrete, or yeah, in your mix? Self-compacting property, anti-washout admixture, pre-packed grouts. Which of these are important and why? You can, I have allowed your microphone, so you can just unmute yourself and speak, or else you can raise your hands. You can respond in the chat section. Yes? Okay. Let's discuss. So, while carrying out a concreting under the water, essentially we face issues of compaction because when we normally do a compaction of concrete, it is based on vibration, and when we apply a vibration to the concrete, we allow the concrete to settle by the effect of gravity, to get compacted by the effect of gravity, while driving out all the air voids that might be trapped within the concrete mix, right? So vibration is based on, it's an additional effort that you're putting. So vibration is basically additional effort, additional compaction effort, because all the types of concretes do get compacted by their own weight, right? But by providing an external vibration, we are providing an additional compaction effort for the concrete to increase in density slash get compacted by the effect of gravity, right? This is the first, and drive out the air voids entrapped within the fresh concrete. But while carrying out a concreting application underwater, we cannot provide uh, this vibrational compaction compactive effort, because first of all, when you're carrying out the concreting underwater, we do experience the the buoyant force, right, from the water. So the concrete is not having its original weight. It's having a reduced buoyant weight. First of all, that is reducing the compacting effort. Again, you cannot disturb the concrete much, because otherwise the cement will get mixed up with the water, and we do not want that. So in order to avoid this disturbance, high amount of disturbance in underwater concreting, we cannot carry out a compaction underwater. So what essentially can we do is we can engineer the concrete mix designs in such a way that it we can get the strength, we can get the kind of flow that we want in concrete, and we can also get the kind of durability, while ensuring that we need not provide in external compaction. How do we ensure that? First of all, we can go for self-compacting concretes. Self-compacting concretes, as we have already discussed, they do not need any external effort for compaction. They can, on their, by their self viscous drag, they can drive all the paste, the cement paste can drive all the aggregates around, and can occupy all the shape that the formwork has to provide. So it can cover all the area within the formwork itself. So self-compacting concrete is the first recommendation. Then what is anti-washout admixture? Essentially, in the case of underwater concreting, you want the cement paste to stiffen faster. You want to increase the yield stress faster, so that the cement doesn't wash out from the concrete itself due to the impact with the water around it. It doesn't get washed out, and therefore you use these kind of admixtures which enhance, like there are viscosity modifying admixtures as well. These admixtures essentially enhance the rheological properties within the concrete. They increase the stiffness in the concrete and the cohesion in the cement, so that the cement doesn't get mixed up with the water and doesn't get washed out. So we also want anti-washout admixture. And then what is a pre-packed grout? So in underwater construction, as this was also discussed in the lecture as well, let's say you're trying to construct a well underwater, right? You want to construct a well, and in order to construct that well, um, first what you do is you place the aggregates of different sizes of the different grading that you want in your concrete. So you place the aggregates first, and then you have already placed the grout pipes from the top, in which the grout is flown, the grout is pumped under pressure. So these are grout, cement grout is pumped under pressure, and due to its self-compacting nature, and cement paste in itself is a flowy material, so it will occupy all the voids within the aggregates. So now that the cement grout has already covered all the void spaces within the aggregates, then you place sand on top of it, And similarly, at the top, again, you place aggregates over here, right? So this is how underwater concreting is done. And these pre-packed grouts are, pumped into the well in a pressurized condition so that they will occupy all the voids within the aggregates. And that's how the concrete get mixed within under the water. So these are also essential for carrying out concreting underwater. So the correct answer to this question is 1, 2, and 3, right? We need to have a self-compacting mix. We want to anti-washout admixture so that the yield stress and viscosity increase faster and the cement doesn't get washed out by water. And then finally, we want pre-packed grouts to be pressurized, pumped into the, uh, I mean, underwater area in a pressurized manner. Right. Moving on to the fourth question, if the pressure at inlet is 5,000 pascals, internal diameter of the pipe, the hose pipe, is 15 centimeters, and flow resistance per unit area of the hose pipe is 3.75 pascals. For saturated concrete, maximum pumpable distance will be how much? 48 meters, 45 meters, 50 meters, 55 meters. This is related to the pumping effect. And the catchy phrase over here is saturated concrete. Yes, anyone would like to answer to this question? For saturated concrete, you have to calculate the maximum distance when these parameters have been given to you. The pressure at the inlet is given, the diameter of the hose pipe used for pumping is given, and the flow resistance per unit area of the pipe is given. Yes, anyone? Have you calculated this? What is a saturated concrete? How can you distinguish between the saturation level of concrete, or what is a saturated concrete person? Yes, anyone would like to answer this question? All right. Mm, A saturated concrete is a concrete which has enough water in it, so that it forms a the water gets mixed with the cement and forms a lubrication layer. So it this concrete has enough water so that it fills in all the air voids in the concrete, as well as it forms a lubrication layer for the concrete, so that it aids the concrete to flow. It helps the concrete in flowing. So that is exactly what a saturated concrete is. I'll just mention over here: enough water to fill in all the voids, as well as produce a lubricating layer. This lubricating layer actually forms, so this lubricating layer is made up of the water and cement. So this cement paste gets ejected out of the concrete while the concrete is getting pumped through a hose pipe, and this lubricating layer forms a boundary at the surface of the pipe itself. So it forms a boundary at the surface of the pipe, and the rest of the concrete, the resistance to the flow of the rest of the concrete is reduced because of this lubricating layer, and therefore the pumping effect required for, I mean, transporting the concrete from a place to another place is reduced because of this lubricating layer. So the enough water must be present in your concrete in order to produce this lubricating layer, and when you have that amount of water, that your concrete is called saturated concrete. Now how do you calculate this? So it was discussed in the lecture slides as well, as I have taken one of these slides. So for saturated concrete, here is the relation for calculating the uh, pump pressure at a distance x from the inlet. So that goes as P is equal to P0 minus 4 times Rx divided by di, where x is the distance at which you're trying to measure the pump pressure, uh, and di is the diameter of the hose pipe. R is the resistance or the flow resistance per unit area of the pipe, and P naught is the inlet pressure that you're providing at the pump. But yeah, in this case, we need to calculate the maximum pumpable distance that we can achieve with all these parameters. So P naught is given to us, P0 or P naught is given to us, that is 5,000 pascals. Internal diameter DI is given as 15 centimeters, so that will be 0.15 meters. And then flow resistance per unit area R is given as 3.75 pascals. So X max will be 5,000 into 0.15 divided by 4 times 3.75. So that will give you the value of 50 meters. 5,000 0.15 divided by 4 into 3.75. Yeah, the answer to this question is 50. So you'll be able to pump the concrete to 50 meters distance maximum. After that, the pump pressure, I mean, at 50 meters, the pressure will be zero. So the maximum distance that you can pump this concrete to will be within 50 meters. So yeah, I hope that is clear to you. Moving on to the fifth question: what can be the effect of pumping on the concrete through aluminum pipes? What can be the effect of pumping on concrete through aluminum pipes? And there are four effects given, which of you have to choose one or a combination of these effects: drier consistency, increase in temperature, slight decrease in air content, decrease in strength. Which of these can be the effect of pumping of on concrete through aluminum pipes? Pumping of concrete through aluminum pipes. Please. Yes? It was mentioned in the lecture that pumping of concrete through aluminum pipes is not recommended. Why is it not recommended? What happens when you pump your concrete through aluminum pipes? Yes, anyone? Anyone would like to answer this question? Does it result in drier consistency? Does it increase the temperature of the concrete? Would it slightly decrease the air content, or would it decrease the strength? Yes, anyone? What happens when you pump your concrete through aluminum pipes? Think of it this way. Does aluminum react with concrete? If it reacts, then what does it do?
Sir,
We've already
would
discussed this in.
increase the temperature also, sir.
Right. Thank you, Srinivasan. Yes, it will increase the temperature. What else? Why would it increase the temperature, Srinivasan? Can you answer that?
Actually, continue flow, sir. Aluminum,
Pardon?
continue flow, sir. Concrete, continue flow.
Okay.
That time increase the temperature, sir.
Okay. All right.
Yes, sir.
All right. Yeah. What else could be the reason? Well, I mean, what other effects can you see when you pump the concrete through aluminum pipes? One is increase in the temperature. So I guess what Srinivasan means to say is that when you continuously put some work on the concrete, when you continuously pump it or try to transport it, that external work that you're doing over the concrete, that increases the temperature. Okay, yeah, that could be partly correct. What else could happen? Drier consistency, slightly decrease in the air content, decrease in the strength. Yes, anyone? Anyone else? Thank you, Srinivasan. Would you like to answer? I mean, would you like to also mention other effects as well? The other effects? So, all of these options already have two in them. Increase in temperature is for sure there. But what else? Yes, Vidya? If you're trying to say something, you're not audible to us? I see
Sir,
that your
increase
Vidya, your voice is breaking. Vidya, if you can hear us, your voice is breaking and we can't hear you properly. Would you try rejoining the session again? Would you try leaving the session and rejoining?
sir, increase the temperature, increase the strength because we are kind of concrete. Okay, sir. Okay, sir.
Yeah, yeah. All right. We are waiting for you. Yes, anyone else while we are waiting for our answer? What happens when you pump your concrete through aluminum pipes? Can aluminum exist as aluminum itself in nature, or does it acquire any other form? Is that form present in cement or concrete, any of the parts of concrete? Is it reactive? If it reacts, what does it do? How does it affect the reactions? Are the reactions taking place within the concrete? Yes, anyone?
Hello.
Yes, Vidya, you're audible now. You can go ahead. Hello? Hello? Vidya, are you there?
Increase in the it's increase in the
Again, your voice is breaking actually. Would you like to answer it in the chat?
sir, it's increase in the temperature, decrease in the strength, sir, because of heat titration occurs in the concrete.
Right. Decrease in the strength due to higher heat of hydration, you mean to say? Okay. All right. Okay. Thank you, Vidya and Srinivasan. Yes, the correct answer to this question is
Sir, it's increase in the temperature, decrease in the strength because of heat titration. Concrete. Hello.
yes, Vidya.
Hello.
Yes.
Yes, sir. Audible, sir?
Yeah, yeah, your
Hello.
voice is breaking in between. Yeah, you mentioned decrease in the strength and increase in temperature. And why? Why did you mention that? What is the reason that you mentioned? All right, let's discuss all of these properties. So when you have aluminum pipes, and aluminum as a metal itself cannot exist, aluminum will not exist directly, or aluminum is
Yes,
not
sir.
Very
heat
stable.
hydration occurs in concrete.
Yeah, right. Thank you, Vidya. Under atmospheric conditions.
Sir, hello?
Yes, Vidya.
Yes. Heat of hydration occurs. Heat of hydration occurs in concrete, sir.
Right. Heat of hydration, and that decreases the strength, right? Okay, thank you. Yeah. So I was saying that aluminum is directly not very stable, meaning that it reacts with when it comes in the atmosphere, and therefore the exposed layer, the exposed outer layer forms alumina. So alumina is basically the oxide of iron. So this is how we know the oxide of ferrous ions is rust itself. And in case of aluminum, the rust is alumina, and the when aluminum is directly in contact with air, the exposed layer or the exposed surfaces of aluminum form alumina, and this exposed surfaces have sometimes might have free alumina or free aluminum oxide available on the surfaces, and when concrete flows through these surfaces, this free alumina or the oxide of aluminum can mix with the concrete itself. So free alumina plus concrete, this can mix with the inside the concrete, and therefore the Al2O3 content in the concrete might increase. Now we have also discussed this in the previous sessions as well. When you have a lot of aluminates are basically C3A, and they are again a source of aluminum or alumina. So C3A aluminates, these are very fast reacting species, so very fast reacting, and have very high heat of hydration. All right. Now, when you make your concrete flow through aluminum pipes, the free alumina on the surface of these pipes might get mixed with the concrete, and therefore the total aluminum concentration within the concrete or within the cementitious matrix will increase, which will further drive the reaction rate into a faster zone. Therefore, due to the fast reaction and the high heat of hydration involved with the aluminate hydration, there will be an increase in the temperature first. Secondly, due to faster reaction, the consistency or the loss of slump, as we call it, the consistency will drop faster. So we'll end up with a drier mix, as the slump loss will be faster in this case. And again, we have seen that when you have too much of alumina or aluminates in the mix in the cement, the strength is compromised, the strength is reduced. Therefore we don't want very fast reacting species with very high heat of hydration. Rather, we want those species which react gradually but keep reacting for longer durations, so that all of the volume is covered with the hydration products, and those are A-light and B-light. So we don't want much of the aluminates or very high amount of aluminates in the mix. That will result in drier mixes, that will reduce the consistency, that will reduce the setting time, and that will increase the temperatures to very high levels. Therefore, when you increase the alumina or the aluminum concentration in the system, and the alumina coming from these pipes, it'll raise the temperature of the concrete mix. It will result in a drier consistency, and due to the very high heat of hydration involved in the initial duration, the later strength of the concrete will be reduced. So there will be there will be a decrease in the strength as well. So the correct answer to this question is 1, 2, and 4. All right. And yeah, the third property was slight decrease in air content. No, basically, when you have a drier mix, as we are saying that if you have a drier consistency in the concrete, that will increase the air content. That won't reduce the air content. When you have a stiffer mix, you have a higher air content. When you have a flowy self-compacting kind of a mix, the air content is reduced in that. So that is not a correct answer. It will rather increase the air content in the mix, not reduce it. So the correct answer to this question are 1, 2, and 4. That is dry consistency, increase in temperature, and decrease in strength. Right. Moving on to the sixth question, you have to match the following considering the recommendation of Indian standards IS 456 on curing. So on the left side, different conditions or different types of cement have been given, and you have to match with the corresponding curing duration that has been mentioned in the Indian standard IS 456 2000. What is the curing duration recommended by the standards for OPC, for blended cements with mineral admixtures, and for dry and hot conditions of concreting? Yes, anyone? Would you like to answer this question? Yes. What are the recommendations of Indian standards IS 456 on curing of different types of cements and for different conditions of
For
concreting?
OPC, 7 days.
For OPC, it is 7 days. Yes, right. Thank you, Srinivasan.
Yes, sir. Blended is 14 days. Sir.
Okay, blended is 14 days.
Blended cement 14 days. Sir.
Blended is 14 days.
Dry and
Okay,
hot conditions. Yes, sir. Dry and hot condition 10 days. Sir.
okay. Yeah. So actually,
Regarding IS 456.
right. I have it here over in the next part. These are the clauses of the Indian standards. So Indian Standard IS 456 2000. So for moist curing, exposed surfaces of concrete shall be kept continuously in a damp or wet condition by ponding or by covering with a layer of sacking, canvas, hessian, or similar materials. So either you have to completely submerge it by ponding, or else you can cover the surfaces with using some layered materials like sacks or canvas or jute bags or whatever it is, and kept constantly wet for at least 7 days from the date of placing concrete in case of ordinary Portland cement. So yeah, this is one should be matched with one, and at least 10 days where mineral admixtures of blended cement are used. So for blended cements, it is actually recommended for 10 days. And then the code says the period of concreting, period of curing shall not be less than 10 days for concrete exposed to dry and hot weather conditions. But in the case of concrete where mineral admixtures or blended cements are used, it is recommended that above minimum periods may be extended to 14 days. So if for normally for dry and hot conditions it should be 10 days, but if you're using blended cements or cements or concretes with mineral admixtures like fly ash, slag, or silica fume, or any other supplementary cementitious material, then for dry and hot condition concreting with mineral admixtures, you have to increase that value to 14 days. So the correct answer to this question is actually 1 is matched with 1, 2 with 3, and 3 with 2. So there is actually,
Yes.
there is a catch over here. If you're using mineral admixtures in your concrete, or you're using blended cements in your concrete, and you're doing the concreting in a hot, dry and hot condition, then you have to extend the period of curing from 10 days to 14 days. So yeah, so I hope that was clear. This is the correct answer to the question. Moving on to the last question. If a thin concrete section, oh, I don't think this is the last. Yeah, I don't think no, this is not the last question. The seventh question goes: if a thin concrete section having reinforcement congestion is in a plastic stage, what is the desirable head diameter of the immersion vibrator? So you have to carry out a vibrator compaction in a thin concrete section having reinforcement congestion. There's a reinforcement congestion. I mean, of course, the concrete is in plastic stage. And so, what is the desirable head diameter of the immersion vibrator in this case? Yes, anyone?
In plastic stage, you can't get only low viscosity, sir. So
In
20 to 40 is enough.
right. Okay. Yeah. Plastic stage basically means when the concrete is flowy or it is in a fresh state. So yeah, okay, 20 to 40 ml is the right answer, but you also have to focus on the other two aspects mentioned in the question. It's a thin concrete section having reinforcement congestion, like a thin slab per se, which has a high or heavy reinforcement congestion, and the concrete section is in itself is thin as well. So there you want to have the vibrator head as small as possible, because the the reinforcing bars are placed very close to each other, and in order for the concrete to move around and occupy all the spaces within the reinforcing bars, you have to provide the vibration at different locations. You have to move around around the formwork, and you have to vibrate the concrete at maximum possible locations, so that all the cement and concrete flows through the reinforcing bars and covers all the voids or all the spaces within the reinforcing bars. So if you have to place the needle or the vibrator, the immersion vibrator head, in between the reinforcing bars, which is very closely spaced, therefore you need to have as a small a head of the vibrator as possible. And in this case, the minimum size of the head of the vibrator that we generally use is 20 to 40 mm. Therefore, we want to go with that size. Thin concrete section again. When you have a thin concrete section, it is expected that you'll have a congestion of the reinforcement, like we have in the case of slabs, thin slabs, right? So this is the correct answer to the question. And I have taken this picture from the slides itself, and you can see here. So this is the head dia of the vibrator, ranging from 20 mm to 180 mm. This is the the frequency of the vibration. So this is the frequency of vibration. This is the average amplitude of the vibration, and the radii of the action, the radius of the action of vibration. I mean, the radius at till which it can provide the vibration or the compaction action. So that is also mentioned. So for a 20 to 40 dia, it can only provide you a vibration action till 8 to 15 at 15 centimeters radius, right? For a 130 to 180 diameter, it can provide compaction effort till 40 to 61 centimeters of radius. And then there is compaction rate, and finally the application. And in application for 20 to 40 dia, it is mentioned that plastic, thin section, and congestion of reinforcement. So C is congestion, P is plastic, when the concrete is plastic in nature or is flowy. So you can just make your way with a small vibrator head. If it is stiff mix, you have to increase the size of the vibrator. Then it's a thin element, thin wall or thin slab, thin element. Again, as you increase the head dia, the application also changes. Like for larger sections like walls or columns or beams, you have to increase the head dia. The frequency, you see, that decreases and the amplitude increases. So amplitude of vibration increasing, meaning that the head of the needle vibrator would be moving much more with respect to its origin position as compared to the smaller dia heads. So the amplitude increases. When the amplitude increases, the radii also increases. So you can see over here, the amplitude increases. Sorry. Oh, I'll just So as the amplitude increases, the radii also increases, the radius of action also increases, and the frequency decreases. So this way the frequency increases. So the frequency increases this way. So the frequency decreases, the amplitude increases, and the radius of action till which it can provide the compactive effect also increases. So as we move on towards larger head dia of the vibrators, we can see that the type of application also changes from very thin wall elements for 20 to 40 dia to massive concretes or mass concretes at 130 to 180 dia. For mass concretes, these are very huge sections of concretes, and therefore you want to, and they have a lot of reinforcement as well, heavy reinforcement congestion as well. So you want to provide, I mean, the head of the dia has to be larger in order to provide the compactive effect to a larger radius. So you can see the radii action also increases from 8 cm till 40 to 60 cm at 130 to 180, right? Moving on to the eighth question. When a concrete of low slump is placed in thin section by free fall, then poor vibration can result in what kind of imperfection? Subsidence cracking, honeycomb, blow or bug holes? None of the above. I'll just highlight all the phrases in the question that are important to us. The concrete is of low slump, is placed in a thin section by free fall, and poor vibration is observed. Poor vibration is provided to it. So what can be the result of, what kind of a imperfection would you see in this kind of a condition?
Honeycomb, like
Honeycomb, right? Yeah, that's the correct answer to this
regarding poor
question.
vibrations, sir.
Yeah, poor vibration would result in honeycombing. And what is honeycombing? I have taken these pictures from internet. So I just forgot to mention over here. Anyway, these pictures have been taken from internet, and you can see um, these two are honeycombing. Sorry, these two are honeycombing. So honeycombing can occur when you let the concrete. It generally occurs in concrete with very low slumps or very low flowability, and when you let the concrete free fall on its own from a height, uh, it doesn't. It doesn't get compacted much, and again on top of it, you provide very poor vibration to it. So that will result in improper compaction within the concrete. When you have improper compaction within the concrete, the cement paste or the cement paste in the total concrete matrix is not able to flow around the aggregates and cover all the areas. So you'll have these stony patches on your surfaces. These stony patches on your surfaces of this majorly occurs in thin concrete elements, because again, when you have a reinforcement congestion and you're not providing enough vibration, the aggregates get clogged within the reinforcements, while the cement paste is not able to flow throughout the homogeneously throughout the concrete formwork, and therefore you can see these stony patches or exposed aggregates with voids in between them, and that is called as honeycombing. Again, honeycombing can also result in very high slump mixes sometimes when you have high levels of segregation, and you let the aggregates settle down in the formwork itself. So generally, what people do in cases of high levels of segregation, they wait for some time before pouring the concrete in the formwork itself. They wait for some time so that the segregation goes away, and they obtain a stable, homogeneous mix, cohesive mix of the concrete, and then only they pour the concrete. This basically happens when you have very high retention times of concrete and you are adding lots of admixture to it. So that results in some kind of segregation at the beginning, but at the time of pouring, the segregation rate gets reduced and the concrete is homogeneous. But if you pour the segregating mix in the formwork itself while it is still segregating, then the aggregates, the large aggregates or the boulders will settle down, while the cement paste or the poured water will rise onto the top, and you can see in this structure element, which is a column, you can see that the aggregates have settled down to the bottom, and they are producing a honeycombing, while the top portion has paste in it. So this is due to segregation. Right, when you have high levels of segregation, the aggregates settle down and they produce this honeycombing at the bottom of this heavy structural elements, while on the top layers you can see that there is still cement paste, and homogeneous mix is somewhat visible to you. Now, I want to also discuss what is subsidence cracking and blow or bug holes in what that is mentioned in this question. Subsidence cracking is, we have already discussed this, I guess, in previous sessions as well. It results from one of the types of shrinkages we have already discussed, the chemical shrinkage, plastic shrinkage, and all that. We have discussed this in the previous sections. And subsidence cracking occurs due to subsidence of the concrete. So as we have discussed, the concrete generally subsides due to self-desiccation, meaning that the water gets consumed, and that increases the capillary forces and it causes a shrinkage in the concrete. And when on top of it you have bleeding in the concrete, the bleed water rises on the top of the concrete and gets accumulated on its surface, top surface. When this bleed water dries out, that results in plastic shrinkage. So you can see that in this element, the bleed water that was initially accumulated over the top has dried out and caused shrinkage within the on the concrete surface. So you can see that there are patches of high cement. These are patches of high cement content, while these are normal patches. So high cement, well, normal cement, and where there is high patches of high cement content, that means that there was bleeding on this surface, and now the water has dried out and caused a plastic shrinkage in the concrete. And due to this plastic shrinkage, you can observe these map cracks that come over the concrete surface. So ultimately, this cracks broaden, and that will result in the delamination of the top surface of the concrete. So this is called subsidence cracking. What are blow or bug holes? Blow or bug holes are essentially these large holes of around roughly 10 mm size or larger that occur at the surface of the concrete, which is attached to the formwork, and that usually can occur due to, let's say, very high amount of use of lubricants on the formwork surface. So sometimes it might so happen that the aggregates would be stuck at that surface initially, at that point initially, but due to the high lubrication, with time the aggregate settle down, and now the concrete has already hardened, so it will leave an impression of a hole kind of a hole that is introduced on the surface of the concrete. So these blow or bug holes are different from honeycombing, because honeycombing is the I mean, all the concrete is visible, but it is majorly stony. The paste part is not visible there. But bug holes or stone holes are present within the homogeneous concrete itself, and that is produced due to sometimes due to high lubrication, due to high lubrication or inadequate vibration as well. So sometimes due to inadequate vibrations also, you can observe these blower bug holes, right? All right. So the correct answer to this question was actually honeycombing. Due to poor vibration and for a low slump concrete, this is the kind of imperfection you would observe in this situation. So yeah, that's the end to the assignment questions of week 7. Now, if you have any questions, we can discuss them. If you have any queries or doubts, we can discuss them now. The session will go on till 8 p.m. If you don't have any questions, you can leave. Otherwise, if you have any questions, you can stay and ask them. I'll answer to them. Right? Yes. Does anyone have any questions? All right. I'm muting myself for now. If you have any questions, then you can raise your hands or you can just unmute yourself and speak, and I'll respond. Yes, Lolita. Okay. Yes, Lolita, you have raised your hand. Do you have any question?
Yes, sir. Good evening, sir.
Good evening.
I just wanted to know if you can explain the week 5 assignment 5 question from 1 to 4.
Week 5, assignment 5 questions. We have already taken up
Yes, sir. Is
this.
that possible? Yes.
Um,
Okay, sir. I'll refer to the video, sir.
yeah,
I'll
you
refer
can
to the
see,
video
you
link,
can
sir.
check out the videos and yeah, you'll find them. These
Sure,
were the week
sure.
7
Thank you. Thank you,
assignment
sir.
7 questions. Yeah, all right.
Right. I understand. Right, sir.
All right. Okay, all the best. Yes, anyone else have any questions? You can look it up on the videos, and if you still don't understand, then you can ask your questions in the next session, right?
Good evening, sir.
Yes, good evening, Srinivas.
Actually, apart from these assignment questions, sir, general questions, sir,
Yeah,
last week I cast on beam, sir.
pardon?
I used expiry supervisor, sir.
Sorry, pardon, what did you say in the first place?
I used expiry supervisor, sir.
No, beam, you trying to
Yes,
construct
I
a
cast a
beam?
beam, sir. Reinforced beam, sir.
Reinforced beam,
Used
okay.
expiry supervisors. Next day, demo rating, sir. The concrete is demolished, sir. Everything, they say, the bonding action not in concrete, sir. Regarding,
Mm, okay, let me just tell you what I understood from your question. You added a super plasticizer for in a concrete,
supervisors,
and
yes,
you
yes,
cast a reinforced concrete beam, and the beam got
yes, sir.
demolished.
Demolished, sir.
I mean, it got I mean, it got demolished as when someone just broke it, or it broke it on its own.
No, well, yes, sir, broke it, sir.
It broke it on its own.
Aggregates, and, yes, sir. Fine aggregate, coarse aggregate, everything is separate, sir.
Okay. What is the height of the structure
Used
that
to
you?
supply Gilenium, sir. Gilenium, actually.
Pardon?
Gilenium, 8233, sir.
8233?
Gilenium, superblast is naming, sir.
No, no, no. I don't
Actually,
want the. I
actually,
don't. Sorry. I don't want the super plasticizer name or the brand or the company. That is not relevant to us. Can you tell me
yes, yes, yes.
what is the height of the building that you constructed and which part of the building
No,
that
so small
you?
beings for testing purposes, only
Oh,
for
all right.
testing purposes.
Okay. You placed it in a concrete beam mold of what,
Yes,
500
yes,
mm
yes,
size,
yes, yes.
100 mm by 500 mm.
700 and 700 into 150, sir.
Oh, 150 by 700. All right.
Yes,
And
yes,
so
yes,
what was the
yes.
maximum size of aggregate in your concrete mix?
20 mm, sir.
20 mm. Okay.
Yes, sir.
All right. And at
Water cement ratio is
on the day of
0.36.
molding itself, it got
Next, next,
broken.
next, next day, sir, 20, after 24 hours.
So after 24 hours, it got
Next day,
broken
sir.
when you tried to.
Yes, yes, yes.
Okay. What was the kind of the mix? Like, was it
M25, sir.
M25? And
Yes, sir.
just wait for a minute.
Water cement ratio 0.36, sir.
नीचे जब पटकते हो तो बीम अपने आप टूट जाती है क्योंकि टेंशन में बहुत वीक होता है तो डिमोल्डिंग बहुत ध्यान से करनी पड़ती है इन द डिफेंस ऑफ फल
Okay. Yeah. And water to cement ratio was how much? 0.36.
Yes, yes, 0.36, sir.
And what was the slump that you mentioned?
50 to 70 mm, sir.
50 to 70 mm.
Yes, sir.
Oh, it was I
So
mean, it was
we
kind
are
of a
adding the
stiff mix.
super plastic.
So, what was
Super,
the
yes, sir.
amount of super plasticizer that you used?
0.002, 30 ml for the beam, sir.
TML for a beam. Um,
Yes, sir.
uh, yeah, I mean, it should be around how much? Let's calculate the volume. So 150 to 150,
I think 0.0028. I think.
115 to 115 to 700 divided by
Mm,
1000. That is C in cubic. Yeah, that's very low actually.
Oh, okay, okay, sir, okay, sir.
Yeah. So I don't think this is due
Okay.
to I mean any concrete mix design issue. Like the super plasticizer content is so low that it won't retard the concrete mix so much that it'll break on its own. So
Yes, yes.
because the super plasticizer content is low, I guess when you while demolding it, did you do it properly so that did not
Uh,
have a lot of
Properly demolited, sir.
impact, like it did not break due to hitting it on the surface while demolding it, or due to impact or so on? No?
Okay, sir. Okay, sir.
Did you? No, I mean, did you ensure that it did not break due to hitting it? Because anyway, the concrete is stiff.
No,
So
no, sir. Properly demolited, sir.
okay. And did you also observe any kind of honeycombing or these kind improper compaction effects?
No, sir. Only it will come some expressive problem. It will come bad smell, sir.
Okay. All right.
Hmm.
Um, I mean, it's not. I don't see any issue with the concrete mix from what all parameters that you said, and I mean the super plasticizer content is so low that it won't retard the mix so much that it won't have a wonder strength. So, and did it break down into like powdery concrete, or did it break into two pieces?
Work in powder, sir.
Okay, okay. What was the sand content in the mix? Was it too mortar like?
Like mortar, sir.
Yeah, so yeah, this might be the issue, because if it breaks into powdery form, there can be two issues with it. Either, so I have
Okay.
seen from my experience itself, if you add too much of the retarder in the concrete, then at one day, I mean while demolding, the concrete is still moist and it has not gained enough strength for it to, I mean, be deformed or demolded. So it breaks into, and even while you carry out a 1 day strength test, you'll see that the concrete doesn't break directly into a brittle form. Rather, it deforms so much so that it'll crumble into small pieces or powder, right? So this
Okay.
happens either when you
Yes, sir.
add a lot of retarder in the super plasticizer. So you first need to ensure that there is not a lot of retarder in the super plasticizer. And when you say that it's a commercial super plasticizer, a PC based commercial super plasticizer, it should not have a lot of retarder. So I don't think that is the reason for your case. The other case, when this kind of a powdery crumbling is observed when you demold your concrete, is when your concrete is over sanded, or it has too much of sand in the mix. So as you
Okay. Yes.
mentioned that it was more motor like, so that
Yes, yes.
increases the void content, the air content in the mix, and again it doesn't provide enough bond strength within the aggregates and the cement paste and the sand. So you need to optimize your concrete mixture. You need to reduce the sand. You need
Exactly.
to increase the aggregates, and you might also need to increase the cement paste content a little bit in order to have that bonding effect in the concrete. When you have too much of the sand and too little of admixture, then you'll
Yes, yes,
essentially
yes.
end
Okay.
up with these kind of powdery crumbles that you see in your mix. So that is probably
Okay.
the
Thank
reason you have too much of sand in your mix. You need to reduce that, and you can increase the cement and aggregate, I mean the coarse aggregates a bit.
you. Thank you, sir.
Okay. And moreover, I guess when you have the maximum size of aggregates as 20 mm, you can directly go with 100 mm by 500 mm beams. You need not go for 150 mm by 700 mm beams. From what I remember from the codal provisions, I guess when the maximum size of aggregates is 40 mm, then you need to go for 150 mm to 700 beams.
Okay. Thank you, sir. Thank you.
19 से ऊपर
Okay. क्या कह रहे हो?
Hello, sir. Sir, am I
Hi,
audible?
Loeta. Yes.
Yes. You just said that if the specimen is like kind of moist, then the strength might be lower on the lower side.
Right.
Am I correct?
Yeah. Yes.
The exact reason for that,
Okay.
if I'm not using any retarder,
No. No. No.
if
No. No. No.
if the normal,
No,
hmm.
no, no.
Yes,
When
sir.
I am telling that the specimen is moist after 1 days, that is because the cement is so retarded. I mean, you have retarded the chemistry of the cement so much that it has not reacted sufficiently to provide you with the strength. So, I mean, when it essentially happens when you use a
Yes, sir. Okay, okay. Yes, sir. Now it is. Hmm. But in that case, if the specimen is still moist, is the reason due to the presence of water in the specimen or presence of any moisture in the specimen? Water, CSHL, right now. React with water. Hmm. Cement. Yeah. Okay. The- mm, mm, mm. Okay. Thank you. Mm. Strength. Mm. 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 Proper mix. Yeah. Yeah. Right. Thank you. Thank you, sir. No questions from my side, sir. Yes, sir. I am assistant. I work as assistant professor here in at Hyderabad in private engineering college.
No, sir. No, sir. Thank you, sir.
Sure, sir. Right. Right. Right.
Thank you,
Thank you.
sir.